All right, so we're going to look at simplifying radicals a little bit further than what we did last week. And just as a review, and this is going to be a review from last week. So let's do number one. We have the square root of 25, x squared, y to the fourth, and z to the 10th. All right, and this part you had last week, and it was one of the worksheets that you had to turn in last week. And so remember, we used a product rule for radicals, which said that, and most of you can go from here to the answer. But let me just remind you about the product rule. So the product rule says that whenever you take the square root or cube root or fourth root or whatever the index may be, you can rewrite it as each individual factor. So the square root of 25, square root of x squared, square root of y to the fourth, square root of z to the 10th. All right, and I don't expect you to do that for this one because that's too easy to do this part. But this what I'm using is the product rule. So remember, the square root of 25 is 5 because 5 times 5 is 25. And the square root of x squared is x because x times x is x squared. And the square root of y to the fourth is y squared because y squared times y squared is y to the fourth. When you multiply like bases, you add exponents. And then the square root of z to the 10th is z to the 5th because z to the 5th times z to the 5th is z to the 10th. We also saw that you can in these cases, you can get the exponent 5, the exponent 2, the exponent 1 by just doing this. You take the exponent of the variable divided by the index. 2 divided by 2 is 1. 4 divided by 2 is 2. 10 divided by 2 is 5. All right, so that's what we also learned last week. Okay, number 2, so that's the answer to number 1. And number 2, we have 4 times the cube root of 8 x to the ninth y to the third. And again, as we go through all of these, remember the directions we usually say simplify. It'll say simplify. And then it'll say assume all variables represent positive numbers. And the reason for that is that way you don't have to worry about having to put any of these in absolute value. So you don't have to worry about that in these lessons right here. Okay, so again, if I use the product rule like I did here, I can do that here. So that'll be 4 times the cube root of 8 times the cube root of x to the ninth times the cube root of y to the third. And so I get 4 times the cube root of 8 is 2 because 2 times itself 3 times is 8. The cube root of x to the ninth is x to the third because x to the third times itself 3 times is x to the ninth. Whenever you multiply like bases, you add exponents. 3 plus 3 plus 3 is 9. And remember that also that other way to think about this, 9 divided by 3 is 3. And then 3 divided by 3 is 1, so that should be y to the first. And it makes sense because y times y times y is y cubed, which is what the radicand was. All right. So the answer for that will be 4 times 2 is 8, so we get 8x cubed y. All right. So that's what we looked at last time. Okay, now what we're going to do now is this. So we're going to simplify radicals. We're going to simplify radicals, but this time it won't be as simple as these were. All right, so let's start out with just numbers for right now. So number 1, we have the square root of 20. Now the problem is that when you look at the square root of 20, you want to simplify. 20 is not a perfect square. There is no number times itself that is 20. So 20 is not a perfect square. But there is a perfect square that goes into 20. So remember your perfect squares. So you got to remember these perfect squares. So your perfect squares are 1, the next one's 4, 9, 16, 25, 36, 49, and so on. So remember how to get those. You get those by saying 1 squared, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. Okay? So if you look at all these perfect squares right here, obviously 1 will go into every number, but there is another one in here, and the largest one that will go into 20, and that is 4. So you want to rewrite this as the square root of 4 times 5. So 4 times 5 is 20. Okay? And then what you're going to do is now you're going to use the product rule that we did earlier. So using the product rule, I get the square root of 4 times 5 is the square root of 4 times the square root of 5. Okay? So the square root of 4 times the square root of 5. And then notice that 4 is a perfect square, and so the square root of 4 is 2. So I can write this as 2. The only perfect square that goes into 5 is 1, so I cannot do anything with that. And so there's your answer. So you get 2 square root of 5. Okay? So that's the answer to that one. Then let's look at another one. Let me go ahead and find my calculator. All right, so let's look at another one. So this is going to be number 2. Number 2, we have this. We have the square root of 32. All right. Now, I can simplify the square root of 32 because there is a perfect square other than 1 here that goes into 32. But keep in mind that 32 is not a perfect square. No number times itself is 32. And you may say 16. Well, be careful. 16 times 16 is not 32, right? So if you use your calculator, 16 times 16, so notice 16 times 16 is 256, okay? But you're on the right track because 16 is a factor of 32, and it's also the largest. Notice that 4 goes into 32, 1 goes into 32, 16 goes into 32, but always use the largest. It makes things so much easier on yourself. So for example, if I use 16, I can write this as the square root of 16 times 2. Okay? And then using the product rule, this becomes the square root of 16 times the square root of 2. And then I can simplify the square root of 16. 16 is a perfect square, right? And so that means that since 16 is a perfect square, the square root of 16 is 4. So this is 4. I cannot simplify the square root of 2. The only perfect square that goes into 2 is 1. And so there's your answer. Okay? Now notice these are the steps using the largest perfect square. But someone could have done this. I just want to show you. So someone could have said, well, could I have used, let's say, 4? Sure you can. So let's see what happens. So if I use 4, remember it's not the largest is 16, but you can still use a perfect square. That's not the largest. You just have more steps to deal with. So 32 is 4 times 8, right? And so that becomes the square root of 4 times the square root of 8. So 4 is a perfect square. So we see 4 is a perfect square. So the square root of 4 is 2. So I get 2 square root of 8. But that's not the answer. Because you see the square root of 8? What other perfect square goes into 8? Well, 4 again, right? So you got to go further. So this becomes 2 times the square root of 4 times 2. 8 is 4 times 2. Then using a product rule again, I get 2 times the square root of 4 times the square root of 2. And now notice the square root of 4 is 2, so I get 2 times this 2 times the square root of 2, and 2 times 2 is 4. So you get 4 square root of 2, which is what we got here. So the point being is that if you use the largest, you save yourself a whole lot of steps. See, it's a lot shorter. The steps are a lot quicker to get to the answer if you use the largest. All right. Now you don't have to use the largest, but you have to go through a little bit more steps to get to the answer. All right, so that was number 3. Now let's look at number 4. So in number 4, number 3, I'm sorry. Let's look at number 3. In number 3, you have the square root of 40 divided by 36. All right, now don't make this difficult. So you see 36 right here, that's a perfect square. So leave it like that. Leave it like that. All right. If you reduce this, if you reduce, you're going to make things a little bit more difficult for you because you're now going to get to a point where you haven't learned yet what to do. So, for example, if you reduce, they're both divisible by in this case 4, right? Actually, you can reduce. If reducing may make it easy. I'll do it both ways. So let's reduce. They're both divisible by 4. So let's do that. So it'll be the square root of 40 divided by 4 is 10. 36 divided by 4 is 9, right? And so now I'm going to rewrite this. Just like the product rule, there's a quotient rule. So your quotient rule, or quotient property. And so if you have the square root of a divided by b, then you can rewrite this as the square root of the numerator divided by the square root of the denominator. And so this becomes the square root of 10 divided by the square root of 9. But the square root of 9, 9 is a perfect square. So that becomes the square root of 10 divided by 3. And I cannot simplify the square root of 10 because the only perfect square that goes into 10 is 1. So for that one, it was actually easier to go ahead and reduce. But it's not always going to be that easy. This one was. But I want to show you a different way. Someone else may not have seen that you could reduce the 40 and 36. Someone else would have left it like this for right now. Okay, that's fine. Let's see what happens. I want to show you something. So you see the different paths that you can take. It's important that you learn all the different ways of coming up with an answer, the different paths that you would take. So if I do it this way, again I use the quotient rule. So the square root of a fraction is the square root of the numerator divided by the square root of the denominator. But I want you to see this. 36 is a perfect square, right? And the square root of 36 is 6. So this is 6 right here. Y'all agree? Okay, you may say, well, that's not the answer here. Well, hold on. Just wait. Let's go to the square root of 40. I'm going to put the square root of 40 right here. Can I simplify the square root of 40? Yes. What is the largest perfect square that goes into 40? The answer is 4. That becomes the square root of 4 times 10. Using that product property, I get the square root of 4 times the square root of 10. The square root of 4 is 2, so this is 2 square root of 10. So that's the numerator. So that's 2 square root of 10. And now reducing the 2 and the 6, I'm going to go ahead and rewrite this over. Reducing the 2 and the 6, 2 and the 2 is 1, 2 and the 6 is 3. And so 1 times the square root of 10 is the square root of 10 divided by 3, which is what we had here. Okay, so the different paths, just know the different paths that you can take to deal with some of those problems. It helps to know the different ways that you can do something. All right, so that was number 3. Now let's look at number 4. Number 4, we have the square root of 216 divided by 16. 216 divided by 16. Okay, so let's kind of use that same idea we did this. We notice that, see this denominator 16? That's a perfect square. So let's go directly and use this quotient property. So I can rewrite this as square root of 216 divided by the square root of 16. And the square root of 16 is 4. Now let's talk about the square root of 216. Let's go off to the side. Can I simplify this? That's the question. You got to ask yourself, can I simplify the square root of 216? Use your calculator. So remember your perfect squares. Your perfect squares. Your perfect squares are 1, 4, 9, 16. The next one will be 25, 36, 49, and so on. They're an infinite number. All right. Let's look at 4. One goes into every number, so let's look at the next one, 4. So 216 divided by 4, let's see what happens. 216 divided by 4 equal, okay, so 216 is divisible by 4, so 4 is a perfect square that goes into 16, but see that 54? It's even, right? So let's see there's something else that another perfect square that may go into 54. So let's look at 9, 54 divided by 9. There you go, right? So 9 is also a perfect square that goes into 216. So I want you to see something. Okay, so watch. 216 is the square root of, so what we did first, we said 4, right? 4 times, so 216 divided by 4 is 54. But I saw that I can simplify 54 further because 9 goes into 54. So that becomes the square root of 4. And then 54 divided by 4, but divided by 9, excuse me, 54 divided by 9 is 6. That's 9 times 6. So now using the product property, I can write this as square root of 4, square root of 9, square root of 6. And the square root of 4 is 2 times, the square root of 9 is 3 times, and I cannot simplify the square root of 6 because the only perfect square that goes into 6 is 1. So I get 2 times 3 is 6, I get 6 square root of 6. So that goes here, 6 square root of 6. Now let's reduce the 6 and the 4. So I get 6 square root of 6 divided by 4, and then reducing, 2 and the 6 is 3, 2 and a 4 is 2, so the answer is 3 square root of 6 divided by 2. Okay, so that's one approach. That's one approach. The other one you could have done was this. So let's think about the other one. So I want you to see something. So you may say, well, it looks like in terms of these perfect squares, it looks like 4 goes into 16. Okay, and 216, let's look at 216. So 216 is also divisible by 4, right? Okay, so let's divide both of these by 4. See what happens. So I get the square root of 54, 216 divided by 4. So notice I'm dividing by 4. Divide by 4. So 216 divided by 4 is 54. 16 divided by 4 is 4. Okay, so now using the quotient property, I can write this as the square root of 54 divided by the square root of 4. The square root of 4 is 2. Now let's get the square root of 54. So the square root of 54, square root of 54, 9 is the largest perfect square that goes into 54. So I can rewrite this as the square root of 9 times, if you can't remember, just say 54 divided by 9, right? So 9 times 6. Okay? And then I can write this as the square root of 9 times the square root of 6. Square root of 9 is 3. So you get 3 square root of 6, and that goes here. And that's the same thing you had here. All right, so different ways of coming up with the same answer. All right, let's look at number 5. Okay, now in number 5, we have this for number 5. Okay, so we have the cube root of negative 24. Cube root of negative 24. Now this time we're dealing with cube roots, so let's remember what our perfect cubes are. Our perfect cubes. So remember our perfect cubes, the way we got our perfect cubes was by saying 1 cubed, 2 cubed, 3 cubed, 4 cubed, and so on. So 1 times itself 3 times is 1, so 1's the smallest. 2 times itself 3 times is 8, so 8's the next perfect cube. 3 times itself 3 times is 27. 4 times itself 3 times is 64, and so on. Okay? So if you look at besides the number 1, if you look at any of these, there is one of these that goes into 24, and that's 8. So I can simplify the square root of a negative 24. So I can rewrite this as a cube root. Make sure you put the index. The index is 3. That's important. If you leave it off, you're now dealing with the square root of negative 8 times 3. Okay, make sure you understand that negative 8 times 3 is a negative 24. Using the product property for radicals, I can rewrite this as the cube root of a negative 8 times the cube root of 3. Now let's look at this. Remember, 8's a perfect cube. So the cube root of negative 8, remember, if you got to think about it, if you got to write it out, you write it out. The cube root of negative 8 means what times itself 3 times is negative 8. Well, the answer is negative 2, right? Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. So that's negative 2 right here. So this is negative 2. The only perfect square that goes into the radicand 3 is 1. So I cannot simplify that. So the answer is going to be negative 2 times the cube root of 3. All right. Let's look at 6. So in number 6, we have 2 times the cube root of 54. So we have 54 again. We dealt with it earlier, but that's fine. Let's just do it again. Oh no, but before it was square root. This is cube root. Okay, so cube root this time. All right, so let's talk about a perfect cubed right here that goes into 54. All right, so let's look at 8. So is 54 divisible by 8? Look at it. Just use your calculator. 54 divided by 8. The answer is no, because you get a decimal. Let's try 27. 54 divided by 27. The answer is yes. So there is a perfect cube that goes into 54, and that's 27. So I'm going to rewrite. I'm going to rewrite. I'm going to go put that here. The cube root of 54 is the cube root of 27 times 2. And put 2 here. Then using the product property, I can rewrite this as a cube root of 27 times the cube root of 2. And the cube root of 27 we know is 3, because 3 times itself 3 times is 27. The only perfect cube that goes into 2 is 1, so I cannot simplify that further. So this is this. So I'm going to put this here. So look what I get. I get 2, bring down the 2, times 3 cube root of 2. 2 times 3 is 6, so the answer will be 6 cube root of 2. All right. Okay, let's do one more. Now notice before I go on, all the problems we've done did not involve any variables. So those 6 problems did not involve any variables. Okay, so let's go to number 7. Number 7, we have 5 times the square root of 18. 5 times the square root of 18. Now this time we're dealing with square root. So what's the largest perfect square that goes into 18? Remember, your perfect squares are let me go ahead and write that down. Your perfect squares are 1, 4, 3 squared is 9, 4 squared is 16, 25, and so on. So the largest perfect square that goes into 18, in fact, there's only 2 perfect squares that go to 18, 1 and 9. Those are the only ones. So we're going to use the largest. The largest is 9. So I'm going to rewrite the square root of 18 as the square root of 9 times 2, because 9 times 2 is 18. Using the product property, I can write that as the square root of 9 times the square root of 2, and the square root of 9 is 3, so you get 3 square root of 2. So that goes here. That's what this is. So this becomes 5 times 3 square root of 2. And then 5 times 3 is 15, so you get 15 square root of 2. Okay? All right, so that part that I just did, and let me go ahead and find the original. So that part that I just did in terms of simplifying radicals involved just numbers for the radicand. Radicand is 20, radicand is 32, and so on. Okay? Now what we're going to do in the next one is we're going to look at simplifying radicals where we're going to get all these variables. All right, so that's what we're going to look at. Okay, so I'm going to go ahead and end that part,